Hey everyone, in this video we're going to take a look at solving some inequalities, and what I have right here is the inequality x minus 2 times x plus 3 is greater than 0, and what I need to do is I first need to find the zeros, and for this that's x equals 2 and negative 3. So then I'm going to look on a number line here, so let's grab a little number line and we'll write down negative 3, I'm going to write down 2. So these two zeros are two cuts on the number line, and they divide it into 1, 2, 3 regions. And I'm going to find some points on each of these regions. So something like here, at 0, that's a good point to look at. I'm going to put that in. I'm going to look at what happens at 0. At 0, we have 0 minus 2 times 0 plus 3. So that's negative 2 times a positive 3, which is less than 0. That means that's false. This doesn't work. That's a bad region. Then I'm going to take another point, like say over here, negative 4. I'm going to look at what happens at negative 4. Negative 4 minus 2 times negative 4 plus 3. That's negative 6 times a negative 1. It's going to be greater than 0. That's the relationship we want. That's a good region. And then lastly, I'm going to look at a point over here. Let's try positive 4. 4 minus 2 times 4 plus 3 is 2 times 7, which is also greater than 0. And this also is a good region that works. And it's only at these zeros that it can change from greater than 0 to less than 0. It has to pass through 0 because these are continuous functions. So now I'm going to go ahead and I'm going to write up my solution using this information. If I'm less than negative 3, I'm okay. And if I'm greater than 2, or if I'm greater than 2, I'm okay. So that's the region of my solution. X needs to be less than negative 3, or x needs to be greater than 2. Great. What about this one over here? Well, this is going to be the same thing. X times x minus 1 times x minus 4, except in this case, what we're going to have is we're going to have an additional region. So we've got, let's see here, 0, 1, 4. 0, 1, and 4. And we're going to test a point in each one of these regions. Now they should alternate because these zeros are all linear. These are all linear zeros. So they should alternate. But I'm going to check just because I want to get it correct. You check to get it correct. So I'm going to test negative 1. Negative 4 here, so this is negative times a negative, right, times a negative, which is less than 0. So this is a good region. I'm going to test between 0 and 1, I guess a half. And this is where we just look at the signs of the relationships rather than what's actually going on, the actual numbers, right? 1/2 is positive, 1/2 minus 1 is going to be negative, 1/2 minus 4 is going to be negative. So in this region we're going to be greater than 0, and then maybe 2. 2 times 2 minus 1 times 2 minus 4 is a positive times a positive times a negative, which is less than 0. And then, 5 is a good region. Or we could even do something really huge like 500, right? 500 times 500 minus 1 times 500 minus 4. That's absolutely positive, positive, and positive. All three of those are absolutely positive, which means this is going to be greater than 0. And as we predicted, it did alternate because these are linear roots, linear zeros. So Less than 0 is good. Between 1 and 4 is good. Those are solutions. Between 0 and 1 is not, and greater than 4 is not. So let's go ahead and let's write up our solution. Our solution is less than 0, so negative infinity to 0, and we are allowed to be at 0 because we have less than or equal to, or we could be between 1 and 4. And if we want to use, instead of interval notation, greater than, less than notation, x less than or equal to 0, or 1 less than or equal to x less than or equal to 4. And that's our solution. That's it for our introduction to solving each inequality and working with inequalities.